Hi, this is Dr. Syed from India. Today I am going to teach you about NEBOSH International General Certificate, Element 11, Part 1A, Fire Hazards and Controls. The basic fire principles are as follows. Fire is a rapid chemical process in which oxygen combines with another substance in the presence of a source of heat energy. The reaction of these elements is called combustion. During this reaction, light, heat, and flames are given off. How the fire can be initiated? There is a fire triangle. The initiation of fire requires the presence of three components in sufficient quantities. Unless you have all these three in sufficient quantities, you never get a rich fire. These three components form a structure known as the fire triangle. If any one of these elements is removed, the fire will be ceased. The heat energy. Heat acts as the source of ignition, and anything which gives off heat can start a fire. The source of ignition is not necessarily a flame or spark or fire itself, but only the heat they give off. It's important to note that the source of heat can't only be equipment and activities by which heat is produced, but it may also include a variety of other circumstances by which heat may not be expected at all. We can indicate a whole range of equipment by which heat can generate when it is in proper use. Some of the examples are welding torches, glow lamps, soldering irons, space heaters, hot plates, oven electric fires, light bulbs, and electric irons. We can also include the use of matches and smoking, but heat may also be produced as a byproduct of other events which are intended or not. Another example is the grinding wheels, which can produce sparks. Electrical equipments may be overloaded and then overheated, and static electricity or an electric short circuits can cause sparking. Heat can also be generated by friction, as and when two pieces of metal rub together without lubrication. The fuel. The fuel for a fire doesn't have to be a recognized fuel in the sense of petrol or gas. It may be any combustible material. Most of these substances are combustible under the right circumstances, but these circumstances may vary for different materials as per the required temperature at which combustions take place. Carbon or hydrocarbon based materials catch fire and burn readily at the sort of temperatures often generated in a workplace or domestic environment. These are the solids such as paper and wood, and gases such as petrol vapor, natural gas, or propane. But some of the other materials may also get combusted at low temperatures. The type of fuel is also an important because of different substances behave in different ways when they get combusted. For example, the amount of flames or smoke they give off may depend upon the temperature and air conditions. So the means of extinguishing the fire may vary. It's more useful if you can understand the types of fuel and the way in which fire are normally classified. This will be discussed in the detail in the other slides. Now we'll see the importance of the oxygen in the fire. The oxygen is an essential element for the combustion and is usually supplied from the surrounding air. But the presence of oxygen may be enhanced by the different other sources of oxygen, such as compressed air. The pure oxygen that we get in gas cylinders and use for the purpose of welding, or by the combustion of peroxides, nitrates, and similar chemicals, oxygen is generated for their own combustion and known as oxidizing agents. The classification of fire. Fire have different classifications. Fire is classified into 5 categories according to the fuel type. The classification is purposely made for identifying the means of extinguishing different types of fire. Class A fire. This type of fire is generated from the solid materials, normally of an organic nature, such as paper, wood, coal, and natural fibers. These fires are usually produce burning embers. Now we are going to discuss about classification of fires. There are 6 types of classifications like A, B, C, D, E, F. For each classification you have different symbol. The Class A fire, this is for solid substances, combustible materials, and the example is wood, paper, textiles. Class B fire, the symbol is different symbol, and the combustible material is liquids. The examples are oil, gasoline, fats. Class C fires, the different symbol is there. The combustible material is gases, and the examples are butane, propane, natural gas. Then Class D fires, the symbol is different symbol. The combustible materials is different combustible materials like magnesium, aluminium, sodium. Then Class E fires, the symbol is different. The combustible material is electrical, that is liquid, solid substances. The examples are plastics. Class F fires, the symbol is different symbol. The combustible material is oil and fats. Then the example is cooking oils, frying fats. Now if you want to consider the extinguishing agents, for Class A, water, foam, ABC powders. For Class B, foam, CO2, ABC, BC powders. For Class C, CO2, BC powder, ABC powder. For class D, dry powder. For class E, non-conductive extinguishing agents. For class F, there is a specific extinguishing agent. Class B fires. This type of fire is generated from flammable liquids or liquefied solids such as petrol, oil, greases, fats and paints. Then class C fires. This type of fire is generated from gases or liquefied gases such as methane, propane and mains gas. Then class D fires. This type of fire is generated from the fuel-like metals such as aluminum, sodium, potassium or magnesium. Class F fires. What are class F fires? This type of fires are generated from the ignition of cooking oils and fats. These fires occur when these oils or fats reach their flash points. So, in this case, the flash point is around 315 centigrade degrees, and these fires can be extremely dangerous and can spread very quickly. Principles of heat transmission and spread of fire. Once a fire has started at a point, the fire tends to spread over the other areas. The fire can spread by means of four methods: convection, conduction, radiation, and direct burning. The convection. Convection is the process by which heat moves through a gas or liquid. When a gas or liquid such as air or water is heated, it expands and becomes lightweight. As a result, it rises in the air and absorbs the cooler air or water in it, and this process creates a current. Convection currents created in the air by fire are a major means of fire spreads. The convection process. You can see in this diagram how the fire continues to grow. In this diagram, the fire is growing in the air. It is getting spread off. These may carry burning materials by the air and can get into contact with other combustible materials. Depending upon the intensity of the fire and the heat generated, it creates strong localized winds by which may fan the flames and cause flare-ups. The conduction process. Heat can be transmitted through certain materials which are known as conductors. These materials get burned themselves and create heat. Particularly in the case of metals, the heat is generated by a fire or by any other source to produce heat. It may be transferred to a separate location where it can act as a source of ignition. Now we are seeing in this diagram the conduction process. There are many buildings with the features of widespread metal structures like steel frames, steel girders, and the services which run through it, such as pipes and various types of ducting. Or seeing a diagram in which there are three processes of the fire, that is convection, conduction, and radiation. We already discussed about all these three processes. We can understand what is convection and what is conduction and what is radiation. Now we will discuss about radiation. Radiation is the process by which energy is lost from a source without direct contact. Heat radiation is the process by which the heat is given off by hot objects and passes through air or certain types of transparent material such as glass. The radiant heat can itself be sufficient to act as a source of ignition. Radiators is an obvious source of heat by which nearby clothes or papers can catch fire. Similarly, electrical bulbs, particularly certain types of spotlights, which consist of a large amount of heat and can burn any fabrics or flammable materials which are too close to the light. Basically, the intensity of radiant heat diminishes with the distance from its source, but it depends on the temperature of the heat source, and heat transfers may take place over quite large distances. The example of a fire accident in one side of a street may be sufficient to ignite the materials on the other side of the street. Now we will see what's direct burning. Direct burning can occur where heat is transferred directly by contact from one substance to another substance. Hence, if a piece of paper catches fire, then the heat can spread to the next piece of paper in the form of flame to the next flammable material until a whole area is set on fire. Similarly, oil-based paint on walls can spread fire. Direct burning can occur within a gap where the wind conditions allow the flames to be fanned and thereby come into contact with other separate combustible materials. The air blow or fanning. The air blow may be like a simply opening a window or door which allows more air into an enclosed space. The localized winds are created by convection processes. Now we will discuss about causes and consequences of fire. Workplace fires are due to the cause of the heat generated by a deliberated work process or accidentally. This is the act of a source of ignition on a combustible material. All such fires can be prevented by an appropriate safety precautions. An increase of the incidence of arson, which may be a reason for a large portion of all fires. As soon as fire has started, It can spread quickly by means of four methods of heat transfer. The most usual method of fire is through direct burning of the materials which contains with the building and by the convection process. Hot gases and smoke can rise up staircases, lift shafts, vertical ducts, floor openings, and can be spread by convection current under the ceiling and other horizontal surfaces through roof spaces, gaps between floors, and false ceiling. The particles of burning materials which are carried by the current may ignite the combustible materials furthermore. When more materials are ignited and the heat is intensified, the volume of these gases and smoke grow more and the spread of the convection current is increased with the help of the spreaded fire. Heat may also be spread by conduction through structural supports materials like steel girders, pipes, and air conditioning ducts. And also by both radiation and conduction process can go through the doors and the other apparent barriers and allow the fire to move from one room to the other room. The losses due to the fire have an impact on the enormous cost both on finance and human being. But most fires can be prevented with a reasonable means. This disruption to the business due to the fire accidents in the form of loss of production, loss of plant and personal injury and loss of life can be a major issue. Even a minor fire accident can disrupt and be a cause of reduction in production. More than 70% of business have been suffered due to a major fire. My dear learners, answer the following questions and show your knowledge. Question number 1. Describe how the following can catch fire. A. Static electricity. B. Friction. C. Space heater. Question number 2. Explain how the fire can spread over to other areas. Question number 3. Explain the following. A. Convection. B. Conduction. C. Radiation. D. Direct burning. Question number 4. Explain how the direct burning can occur. Question number 5. Explain in brief the causes and consequences of fire. My dear learners, this is the end of this topic. Try to read well and answer the questions. Work safely, live safely.